Hi, this is the next lesson on partial fractions. This is type 3, improper fractions. So, if you recall from a previous video, we talked about what an algebraic improper fraction was. If the degree of the numerator is the same or higher than the degree of the denominator, then it is an improper fraction. This is degree 2. This is degree 2. So because the numerator's degree is the same, then this is an improper fraction. And if we have an improper fraction, it means we can physically divide the numerator by the denominator to give a quotient part, a whole part. Now, if you are asked to split a fraction into partial fractions, and that's all they give you, the first thing you have to notice is that it's an improper fraction. So you should always check that first. If it is, then you have to do long division first to extract the quotient part. You can't just go through the motions of splitting into partial fractions because it won't give you the right answer. So the first thing we're going to do is we're going to do long division to extract that quotient part. So using this term here to divide, x squared divided by x squared is 1. 1 times x squared minus 2x minus 3 is x squared minus 2x minus 3. Then we're going to subtract. 0x subtract minus 2x is positive 2x. 3 minus 3 is positive 6. This is degree 1. This is degree 2. We can't go any further. This is the remainder. So the quotient is 1. And then we have a remainder of 2x plus 6 over, and I'm just going to factorize this, x minus 3, x plus 1. So that's what we get from our long division. So this is the quotient, and then this is the remainder. Now what we're going to have to do now is split the remainder, so this bit, into partial fractions. So this is the partial fractions part. And then when we write our final answer, we need to remember to include that 1. So I'm just going to underline that for now, just so we don't lose it. So now the partial fractions, I'm going to concentrate on this fraction here. We've got 2 different linear factors. So 2x plus 6 over x minus 3, x plus 1. We need an a over x minus 3, and we need a b over x plus 1. Now let's equate the numerators. So 2x plus 6 equals, so to get from here to here, we need to times by x plus 1. To get from here to here, we need to times by x minus 3. And then we can substitute. So if I substitute x equals minus 1 to eliminate the a, minus 2 plus 6 is 4. That goes, and then we're left with minus 4b, which means b is minus 1. And then if I substitute x equals 3 in, 2 times 3 plus 6 is 12. This goes, and we're left with 3 plus 1, which is 4a, which means a is 3. So our final answer is going to be 1 plus 3 over x minus 3 minus 1 over x plus 1. That's our final answer. So notice that that improper fraction led to a constant plus a constant over one denominator plus a constant over another denominator. Okay, so if the question looks like that, and that's all you get, you must do long division first. So look for whether it's improper or not, and if it is, you do long division, and then you split the remainder up into partial fractions. Now, some questions will be given like this. Okay, so you can see this is of the same form. We've got a constant plus a constant over one linear factor plus a constant over another linear factor. And actually, probably 80% of the time, they will give it you like this. Now, we could do what we've just done. So we've got a quadratic here, we've got a quadratic here. This is degree 2, this is degree 2, this is an improper fraction. Okay, so the reason why we've got this is because that divided by that gives this whole quotient part here. So we could do what we've just done, divide that by that to get this, and then split the remainder up into these two. That's one option. But actually, because they've already given it us in this form, we know what it's going to look like. We could just go from here and proceed like we would normally when we're doing partial fractions. So I'm going to show you that approach because it's been given to us. We already know the form that it's got to be written in. Okay, so we're going to equate the numerator. So we're going to go from here, and you'll see that this is now a quicker method. So if it's already been set up for you, then I wouldn't go through the motions of actually physically doing long division. Right, imagine there's a 1 there. To get from here to here, we need to multiply by x minus 1, x plus 2. To get from here to here, we need to multiply by x plus 2. And to get from here to here, we need to multiply by x minus 1. So you can see that I've ended up with times in this a by both the factors. Now we can substitute. So if I say that x equals 1, that's 1. So 2 plus 5 is 7. Take 10 is minus 3. That's gone. That's gone. So I've got 1 plus 2, which is 3b, which means b is minus 1. If x equals minus 2, that's going to eliminate that one and that one. So minus 2 squared is 4, times 2 is 8. Take 10 is minus 2, minus 10 is minus 12. That's gone. That's gone. Minus 2 take 1 is minus 3, c. So c is 4. Okay, we've run out of numbers to substitute in. So if you want to, at this stage, substitute 0 in and use that. Or in what I'm going to do is I'm going to equate the coefficients. If I equate the x squared term, the reason why I've chosen that is because there isn't one here or here. So on the left-hand side, the coefficient of x squared is 2. And on the right-hand side, we've got x squared there. So we've got a lots of x squared. So the coefficient of x squared is a, which gives us a is 2. Okay, so now we can just write our answer in. We've got 2. And then we've got minus 1 over x minus 1 plus 4 over x plus 2. So you can see that that method is easier, but it's because we can do that method because we are told what our answer needs to look like. Okay, if you are not told that, then I would do long division first. Right, that's the end of the first part. In the second part, I'm going to look at some slightly harder ones where there's a cubic on the top.